Welcome friends. Today we will learn about some of the solutions to exercise problems related with the IP version 4 addressing topic. First question: what is the size of the address space in each of the following systems? So they have given three subdivisions. First subdivision, a system in which each address is only 16 bits. So we all know that if there are b bits, the total combination possible is 2 power b bits. So straight away we can write the answer as 2 power 16, which is equal to 65,536. So this is the answer for the first subdivision. Second subdivision B, a system in which each address is made of 6 hexadecimal digits. So 6 hexadecimal digits, we all know that hexadecimal digits in binary we can represent in 4 bits. So here they have given us 6 hexadecimal digits. So in binary 4 bits. So totally how many bits? 6 into 4, 24 bits. So totally 24 bits. So total combination is 2 power 24 bits. So this is the answer. Then a system in which each address is made of 4 octal digits. So we know that in binary number systems, 3 bits are separated. Okay, 3 bits can be directly accumulated as a octal representation. So here they have given us 4 octal digits. So 4 into 3, totally 12 bits are there in that system. So 2 power 12 is equal to 4096. Second question, rewrite the following IP addresses using binary notation. So they have given the dotted decimal notation, 3 subdivisions, 3 sub-problems are given, and these dotted decimal notation should be converted into binary notation of 8-bit octets. Right, so the fundamental conversion is each decimal values here 110, 115 and then 88. Each should be divided successively by 2 to get the corresponding binary number or number bits with respect to 8 bits. Okay, so these 8 bits are represented. This is 0110110 is the corresponding binary value for 110, decimal 110. Similarly, 4 zeros 1011 is the binary representation for decimal 11. Similarly, we need to convert each decimal value into equivalent binary with 8-bit representation. So this will give the corresponding answer for you. Third question, rewrite the following IP addresses using dotted decimal notation. Now the reverse. Previous problem, they have given the decimal notation, they have asked us to convert it into binary notation. Here they have given the binary notation and they have asked us to represent in dotted decimal notation. So we need to convert each binary octet values into decimal, that's it. So this first 8 bits we need to convert it into binary. So this is, you can convert by using that weighted method. So it is 0 into 2 power 0, 1 into 2 power 1, 1 into 2 power 2, 1 into 2 power 3, 1 into 2 power 4, 0 into 2 power 5, 1 into 2 power 6, 0 into 2 power 7. So all those values will be added and finally arrived at 94. Similarly, we need to convert each and every 8 octet bits into equivalent decimal. Next problem, find the class of the following classful IP addresses. So they have given the IP address and we need to identify which classes. So in the video lecture we had previously, so we know that classful addresses are divided into 5, class A, B, C, D and E. Now we know the ranges of each classes. So we need to remember that what is the corresponding decimal range as well as what is the corresponding prefix. So for class A the prefix is 0. For class B the prefix is 10. For class C prefix is 110. For class D it is 1110 and for class E is 1111. Okay. Now for this problem, so they have given 130.34.54.12. This is the corresponding decimal values of the address. Now for class A we know that because only 8 bits are represented in the network part. Okay, we need to only note the corresponding the first most part of the corresponding IP address. So with this With this itself we can identify which class it is. Now for class A, because the node part is only 8 bits, and in that 8 bits also the first bit is for prefix, remaining 7 bit is for network. So in that 7 bit, the total combination possible we had in the slide is from 0, 0, 0, that is 7 bits are 0, that is a starting address, network address, and 7 bit, all 7 bits are 1 possible. Okay, so that is a last network address. So from 0, all 7 zeros to all 7 ones, there are totally 128 addresses possible. So 0 to 127 will be the range of class A address. Similarly, if you calculate like this for the subsequent class B and class C, for class B it will be 128 to 129, and for class C it will be 192 to 223. For class D it will be 224 to 239, and for class E it will be 240 to 255. So for one class A I have explained. Similarly, if you calculate the corresponding decimal values, the corresponding ranges will be like this. So because the first one 130 lies between 128 to 191, so this is class B address. Second 200.34.2.1, 200 lies between 192 to 223, so this comes under class C. And finally 245, it is lies between 240 to 255, which is class E address. So in this way only you need to calculate the corresponding class of a particular IP address. Find the class of the following classful IP address. This is easy because previously it was given in decimal. We need to convert the corresponding ranges into decimal values, but in this problem it is easy, where they have given the direct binary notation of the corresponding representation of the IP address. We all know that class A address starts with prefix 0. So you look into the MSD bits, it is 0. Immediately you can identify this is a class A address because the prefix is 0. Second B, so it starts with 1110. Okay, so 1110. So we all know that 1110 is a prefix defined for class D, so it is class D address. 110 is the prefix of the class C now. Okay, so 110 is the MSD bits which is given in the question C, subdivision C, and 110 is a prefix for defined for class C addresses. So this third one comes under class C. Thank you.